Algebra 2 Honors, Lesson 6.2, Solving Quadratic Equations by Graphing. Now, I find it funny that that's the name of my lesson, but I don't agree with it. Generally speaking, a quadratic equation means you set it equal to 0, and you go to solve. And the graphing portion is just the part that helps you find where the zeros are. Now, we can solve it with perfect graphing, a calculator graphing, with factoring, with quadratic formula, but generally speaking, the way that I've seen it done in textbooks, I don't agree with. So, at any rate, the difference between this and the previous lesson is that there's no f of x anymore. Now we set that equal to 0, which gives us our x-intercepts. We call the x-intercepts lots of things. We call it solutions. We call it zeros, which is what the calculator calls it. We call it x-intercepts. We call it roots. And these are the two main ones that we're going to use, zeros and roots. Although we will use them all. I'm fairly sloppy in my talk, hence the reason I'm a math teacher, not an English teacher. But we'll get them all. So here's the only part of the lesson I want you to be clear about, because you'll go and look for the roots and be like, hey, they're not there. What's going on? You could have two solutions. Rephrase that. Two real solutions. And that would look something like this, where it hits twice. Since parabolas aren't always right side up, it could also look like that, where something hits twice. You could have one real solution repeated twice. And what that means is that in an x squared, you should always have two solutions. So when it comes down and hits just once, people say, oh, there's one solution, and then that's it. So no, this would be like the equation we're about to do, which is x minus 4 squared. And it's just x minus 4 repeated twice. And the last one doesn't hit at all. So we'd call that two imaginary solutions. Apologies for the sloppy handwriting, best I can do to fit it in. We'll figure out what those actually are. They'll have the square root of -1 in them, obviously. That's what makes them imaginary. And we'll do that when we go to the quadratic formula. So here it says, graph and find the solutions. Well, first I'm going to move everything over to the right. So I get x squared minus 8x plus 16 equals 0. I'm going to graph that. I'm going to get a axis of symmetry. X equals 4. 1, 2, 3, 4. And I'm going to bring that down. Then I know the vertex is when I plug that back in. 4 squared minus 8 times 4. Remember, I'm just graphing now. I'm not trying to solve it. And that actually equals 0, which is very strange. So the vertex is at 4, 0. The y-intercept is 16. So looking at something like this. And that was pretty horrible. And we'll try that right there. So here is my y-intercept at 0, 16. Here is my vertex and my x-intercept, because they happen to be the same in this case, of 4, 0. Here's my AOS, x equals 4. Now the big deal here is that we're trying to find where it hits the x-axis. In this case, it was right on the vertex. So that was kind of easy. Well, notice that I moved everything to the right. What if I had moved everything to the left? We would have got negative x squared plus 8x minus 16 equals 0. Doesn't matter. People get all upset. Well, then the graph is totally different. What do? I don't understand. That's not what we're doing here. We're finding the solutions. We found it, the x-intercept. There it is. No matter how we solve it, we should get the same solution. So if we graph this, it will just be upside down. It'll still hit in the exact same spot. It'll still have the same roots, the same solution, the same x-intercept. In this case, the vertex is the same. It wouldn't always be. So a lot of people panic about this. Well, I just figured out a graphing. Now you're crossing me up. Don't. This is just to find the roots. If I ask you to graph it, I have to say f of x equals, and then you're graphing that. You can't move it all over to the other side and make it negative. It'd be a different graph. But that's how we do it. Now, again, I've seen texts that say, I'll just ballpark it, get an approximate. We've got too many tools here to start approximating. That's for younger students without the experience. So all we're going to do now is try a couple problems. And we get axis of symmetry, x equals negative 3. Plug it back in. We get a vertex at negative 3, comma, negative 1, I believe. So now I'm getting very quick and simple with my graphing because I'm just looking for the roots. I don't have to make it perfect. I know it's going to have a y-intercept of 0, 8. I'd like to change the color on that so we can see what's going on. And it all looks an awful lot like it hits at negative 2, 0, and negative 4, 0. I can use a calculator, but in this case I can factor it. So x plus 4 times x plus 2 equals 0. X equals negative 4, negative 2. Those are my intercepts. That's what I got. So those are my solutions. I'll show you how to properly factor that, the whole theory behind it in the next lesson. But for right now, okay, fine, it works. You might ask yourself, well, why bother graphing it? I could have just factored it and been done. Yeah, we're trying to tie it all together here. A lot of people do not understand the difference between factoring and graphing and finding the roots. It's the same thing. They really get lost on that. So we're showing both just to make sure. We'll try one more. And again, I'm going to move the x squared over. And so people say, fine, I'll just factor it. And I say, well, you can't. It doesn't factor. So I need my calculator for this one. But let's get the graph up there, see what's going on. Or maybe we'll find out roots are imaginary. I don't have to do anything. Axis of symmetry, x equals negative 6 over 2 equals 3. And the vertex, we plug it back in, we get 9, negative 9, we get 1, and we know it's going up. So there are no solutions here. So we have a 1, 2, 3, 1, goes up here, hits at 10. So no roots, no zeros, no solutions. I don't trust it. Let's try it on the calculator. x squared minus 6x plus 10. X squared minus 6x plus 10 graph. And it takes its time. Doesn't hit, no roots. Looks like we did it right. So by simply graphing, we look and say, no roots. If we're in the mood, we'd get all into the y-intercept is at 0, 10, all that sort of stuff. So now we have this to graph, and I'm not going to move it over even though I should. Let's find the axis of symmetry. X equals -4 over 2 times -1 equals 2. Plug it back in. The vertex equals -4 plus 8 minus 1 equals 3. Some people immediately say, oh, see, it's at 2, 3, and it's going up. Well, it's not going up, it's going down. 1, 2, 3, 4, 5, 6. That should do it. And I'm going to graph the whole thing out. Hopes that it'll help me out here. 2, 3, y-intercept, 0, -1. Looks like it hits at about 0.2. And at about 3.9. Question mark on those. So that would be solving by graphing, but it's really not very accurate. So x squared plus 4x minus 1. Let's put it in. -x squared plus 4x minus 1. Delete, 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 delete. Clear. Clear. There we go. -x squared plus 4x minus 1. Graph it. Looks like I'm pretty accurate. Second, calc 2. Enter. Go up past it. Enter. Gives me a couple lines. Guess at it. -0.27. And we were pretty close. So I'll cross it out. -0.27 and second calc 2. Enter. 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 3.73. 3.73. So those are our solutions. We ballparked them from graphing, but we tightened them up by using the calculator. That's about it. Happy mathing.